Tonight on efficient irrigation for garden, farm, and high tunnels. We're going to start with some of the basics and move right on up here through the evening here, so hopefully we can cover a lot of ground, whether you're a gardener or whether you're a larger commercial grower here. A lot of the same principles actually apply here. The equipment may be different, but the principles actually, like I said, basically should apply here. We're going to start out with a little bit of a questionnaire here. I think Linda's going to put in there. Okay. Multiple answers. And the question is, have you used an irrigation system? And you can check more than one answer here on this here. And we're just trying to get an idea here of what the audience is up to here tonight. Okay, it looks like all the votes are in here, and we can see that about 71% have a hose and sprinkler, 19% have one in their garden, 14% have a field scale, and 43%, not quite half, have used a drip irrigation system in some form or another. So that's really, really good. So at least most people are. Okay, so ready for the next slide here. Plants are made up of 80 to 95% water. And the old saying is irrigation is important, because anytime you can sell water for $1 to $2 a pound by having your plants turgid and all that, you can usually make extra money. Water is needed for all functions of plant life. We're going to kind of get into that here. And a shortage of water, even for a very short time, can have drastic influence on plant growth, fruit yield, and fruit quality. Now the next slide here is a research project we actually had here with a student here at actually Crookston here, about holding water back. And I'm just kind of giving you results. It was kind of a lot more sophisticated than it looks. It was actually done in a high tunnel, or we could kind of control the water. And these are cucumbers. The variety was Sweet Success, for some of you that may be interested in that. But you can see for the whole season we had no breaking in water. Water was done real well with tensiometers or some type of equipment. We see we made about 32 pounds of plant that summer, and then we went about a day without water. Well, we went down to 28 pounds of plant. And people say, well, 4 pounds, a plant, you could be, off that much, and that's probably true. But then we go to 2 days, 48. Now we're dropping 23 pounds of plant, 72 hours without water, which is about 3 days, gets pretty serious. And after 96 hours without water, the plant was basically stunted permanently and never really did come back and make any type of yields. And this is without water, with the plants kind of getting ready to go into peak production. So, there's a lot of damage we can see in the first 3 days before the plants may actually wilt and really look bad. So that's one of the reasons that irrigation is just so important as we, as we think about this. And I always tell people, think of your child, if they said, geez, I really need some water, I'm thirsty, and it was a Friday, and you said, yeah, my little daughter, Susie, you can sure get some by Monday, they'd be pretty unhappy. And and the plants are really no different. So why is water so important here? We know it keeps the plant cells very turgid. It helps control plant temperature, which is a big factor that we're going to get into of when you irrigate, and irrigating for frost and that type of thing. Uptakes of nutrients. We're going to get into that because I don't think people realize how important that is, and keeps the plant metabolism even. And what we don't want is the plant metabolism to go up and down and up and down, because it never goes up to where it was when it starts dropping. And water is very important to complete pollination. We see a lot of the flowers, the inside of the flowers basically drying out first. That's kind of the first thing that happened. The far extremities of the plant suffer, and we kind of really pay the price for that. So I think this next slide is really important here as we talk about water and plant growth. And it's all plant nutrients from the soil are used only by the plants in solution. This is where water is extremely important. You can have lots and lots of nutrients in the soil, all kinds of phosphorus, potash, boron, nitrogen, but if it can't get into a liquid solution, the plants can't really absorb it. And this is where I'll show you some pictures of some tomato disordered where the plants just, the soil was dry, the plants couldn't absorb it, and if that's the case, you might as well not have it in the soil at all. So water helps keep plants at an ideal growing temperature, especially cooling. And you can kind of see some of the data here that we're going to present that maybe on a hot day, taking field corn or sweet corn, going into a warm wind, a 90-degree day, we can use up to nearly a half an inch of water a day. That plant will expire just to keep the plant cool. So we can go through a tremendous amount of problems when we don't have the water to supply that. Then disease control, and the reason that disease control is important, when the plants start wilting, start suffering from water stress, disease just seems to enter in a lot more, and we can end up paying the price for that too. That's just a shot of a blossom end rot on tomatoes. I'm sure a lot of you have seen that. Basically a calcium deficiency. And in almost all Minnesota soils, especially in the northern part of the state here, there's really no excuse for calcium deficiency because our soils are just extremely abundant in in calcium. But even if the water is short for a day or two, it can show up on something like this. It doesn't have to be, short for calcium for a long time. They figure a 48-hour dry period will basically show up as a lot of blossom end rot, in your tomatoes. Water stress, two things. One I talked about, but insects. And, insects are repelled by a lot of plants or attracted, depending on which side of the spectrum you want to be on, by the color of green or color of blue that's actually, in the leaves pigments. And a lot of plants give off pigments that repel insects. A lot of plants are bred that way. But basically, when there's water stress, they lose that color. It's not a spectrum that we can often see with the human eye, but they lose that color, and then insects can basically come in, have more of a tendency to lay their eggs or suck the juices or whatever the situation may be. And then once insects comes in, then the diseases seem to be able to follow because they have a place to enter. And we have to remember these disease spores, a lot of times they can be thousands, even millions on the head of a pin. So it doesn't take much plant damage for them to be able to come in, find a little spot that the insects made, and then start to multiply and destroy the plant. And I'm talking here a lot about, a lot of the blights, a lot of the leaf diseases that can come in, but also things like tomato virus diseases, tobacco mosaic. Usually I'll end up spreading very easily when there's water stress with the plants. So let's define irrigation. And in the simplest terms, irrigation is simply the adding of water to crops by artificial means. We have several types. We have flood irrigation, sprinkler overhead irrigation, and drip irrigation. Flood irrigation is used like in the wild rice areas of northern Minnesota, and actually, down in Texas, where their fields are perfectly level and they can actually flood down furrows. Not really used much at all, if any, in actual crop production for corn, beans, that type of thing in Minnesota. So then we go to sprinkler or overhead irrigation, and actually in Minnesota, that's our number one source for irrigation. This includes center pivots. It includes inline sprinklers, garden sprinklers that go overhead, anything that basically goes overhead. And then the last category is drip irrigation. And drip irrigation is becoming extremely popular. First of all, with gardening, moving on. It's inexpensive. You can do it on a small scale. You can actually do mighty big gardens on a house well. We're going to kind of get into that. High tunnels. You can do some really big high tunnels, produce a lot of crop on a small amount of water. And out in California and states where water is scarce now, they're kind of legislating drip tape be used instead of overhead, because you can probably get by with 20% of the water a lot of times as with overhead and produce the same amount of crop. So, did you have that quiz come in, Linda? Okay. We're going to have another multiple quiz for you, and it's on permits. And most of you really won't need a permit at all, but I just think it's a thing that, we need to know, kind of a fun thing too. So the question is, when do you need a permit? Choose all that apply. So, do you need to apply a permit when it gets dry in the field, or when you use 10,000 gallons or more per day, 50,000 gallons or more per day, when I'm using water from my own well, and when I'm using surface water? Give everybody a chance to reply to that. Still a few coming in. Okay. We'll see that answer in a slide or two, but I see, well, we can talk about it now. 58% says when I use more than 10,000 gallons a day. That's basically the correct answer. There's some more details we'll cover in another slide on that. That is the triggering point is 10,000 gallons a day or 1 million gallons a year. Okay, let's talk a little bit about some of the irrigation facts. The question is, how does overhead increase disease issues? We have a whole section on that, Howard, so we'll be talking about that, about halfway through. So irrigation facts. 1 acre inch is equal to 27,000 gallons of water per acre. Now that's actual water. If you're using drip tape, that's about what it takes. If you're using overhead, you can have evaporation as high as 30%. Put on 27,000 gallons and actually get about 20,000 to go into the soil. So, anything that we can do to conserve water is extremely important. But that 27,000 gallons per acre is one that I really want you to remember as we continue on here this evening. Okay, so here's the one on irrigation permit use. The law is basically in excess of 10,000 gallons per day or 1 million gallons a year. So theoretically, you can easily, in many cases, use enough water that you didn't exceed 10,000 gallons a day, but you met the $1 million a year, requirement. So I'm not saying that if you're using, 11,000 or something like that, they're going to come and make you put a permit in. But in my estimation, most people that go over that go way over that, and then people that are under that are really under that. So just remember that figure too. And there is limitations if you're sucking out of a pond or surface water, 6 acre inches per acre, which is a lot of water. And there's also groundwater limits with your pumping out of wells, about 15 acre inches per year. And a lot of growers last year really got themselves concerned about that 15 acre inches per year. So most wells are given out, just to give you an idea here, our irrigation well is for 50 million gallons a year out of our well, and it costs us about $135 or $140 a year. That's the minimum fee, is about $130 or $140. So just so people are kind of aware of that. So, as we think about, irrigation systems and what might be right for you or the site that you're really on here, and we think about the crop type, the plant spacing, and your planting dates, can be a factor here with irrigation here. Are you using plastic mulch, like in the picture here, the black plastic mulch? What's your field layout? If you're looking at using overhead irrigation, you may not be able to use a traveling gun much or a pivot because your field is just really poorly laid out for that here. What types of soil do you have? And the big thing is, what water supply do you have? And then labor here. And we'll talk about them factors, this evening yet on choosing an irrigation type system. Another thing you have to really think about is your rooting depth of your crops. The crop on the left is asparagus. They say asparagus have the rooting depth up to 8 to 10 feet. Maybe that's a little high, but it's surely 6 to 7 feet. So it can go down and get a lot of water. The slide on the right is onions, and there we're in with just about 6 inches of root system for water. So it's something that you really need to think about your crop, your soil type, and we'll kind of get into soil types here, in a short little while. Okay. Irrigation system needs here. What are you concerned about? Are you concerned about uniform water application, flexible and site-specific control? Are you going to look at putting some type of fertilizer, whether it's organic or not organic, through the irrigation system to feed them plants on a continual basis? You need frost protection. Very, very important things if you're in the strawberry, blueberry, small fruit type business. And then cooling. We do use irrigation, especially solid set and drip tape, to help with cooling in different manners during the extremely warm times of the day. So it's something to really think about here, really what you really want to do. We look at the type of our system, labor operating, if you have to move solid set around or even a center pivot, They're computerized, but they take a lot of time and effort to run. Then we get on to the cost factor. Like I said, with drip tape, you can actually irrigate a lot of land relatively cheap. In a way, not a lot of outlay, but some of the other systems, they have their definite advantages here. So if you're going to do a system, you may want to consider consulting some local experts, from Extension or some of our tech schools to maybe give you a hand here with selecting a type of a system. This is what we call our solid set systems. And solid set is where you have a pipe going up and down every so many rows. Most of them in this area, the pipes are about 40 to 60 foot apart, so they'll do several rows. If you look at the picture on your right, the big picture here, that's a picture of a blueberry field that they're irrigating for frost. Evidently it was in full bloom, irrigating for frost, and you can just see the amount of ice that the water has turned to. Now, the unique thing about water is when it freezes, it actually gives off heat internally. So as long as they keep their system running, from the time it freezes until the time the ice melts off the berries, strawberries, blueberries, whatever, you can actually protect the blossoms. And we protected blossoms down about 18 degrees above zero on certain nights. And it seems like in northern Minnesota, it's always a situation here where we're always fighting frost in one way or another. The little picture on your left is actually snapped out in California. And there they have center pivots, and they start with one side of the field. I'm sorry, I didn't mean center pivots, I mean solid sets, and they just keep moving the pipes across the field as they irrigate. And the advantage, there's some other advantages. The application is extremely accurate. Every inch of the ground, gets water. You can't operate them in wind, which is a big problem with irrigation. Maybe not a 70 or 80 mile an hour wind, but 30 mile an hour wind, and you can do a pretty good job. And there's a lot of pipe floating around that's not too expensive right now. So a lot of people are looking at them. But if you're going to go into small fruit production past the first year, start producing a crop, I think it's almost imperative that you look at this type of systems. Okay, I'm going to get into a little bit of science here, because whether you're a home gardener or whether you're a commercial grower, you can still irrigate with sprinkler systems relatively economically. And it's a function of two things. One is your irrigation nozzle size, and the other is basically pressure. So I look at the second one over that says 40 by 40. That's kind of a good average for a lot of sprinklers. That means it'll do a 40-foot circle, and it'll actually do more than a 40-foot circle, but as you go out past that, the water gets on, quite a bit thinner. So, looking at that, we look at a flow rate of, looking way over to the left now, going down the column, a flow rate of 3 gallons per minute at 45-pound pressure will put on about 0.18 or not quite 0.2 of an inch per hour. Then you can go up with bigger nozzles to 4 gallons per minute, and that's what most of the berry growers run, is somewhere around 4 gallons a minute. You can put on just about 1/4 of an inch of water per hour. And then if you want to go to a 5/32 nozzle, you can put on, not quite a third. So there's different, nozzle types. I'm going to shoot the next slide here. Okay. Small irrigation for gardens and that. You can go back and look at this other chart here. But one nozzle can work really well and do really well in a garden here. I'm just going to kind of give you an example here. Here you have, just a single nozzle out in the garden. And these nozzles will cost somewhere around $8 to $25 a piece, depending on if you want them in plastic or if you want them in brass. The price of brass is getting pretty expensive. Growers are still using brass because it just seems to last longer and be more uniform, but you can get by with plastic very, very well for the home gardener here. So, basically, so you got this 40 by 40 spacing. You're looking at 3 gallons per minute, which is a very, very low flow, even from a house well, using a 1/8 nozzle. So what you're running it comes out to, for every 3 hours that you run it, you put a little over 1/2 inch an acre equivalent, on at one time. And we usually don't recommend putting over 1/2 acre on, 1/2 inch per acre on in one setting unless it's really, really hot and really dry and you have just a tremendous amount of evaporation. So, you can actually go in there and do a good job in your garden with, a hose and a nozzle. Moving up to the next spacing here, if you've got some more flow, running 4 gallons per minute is what we call a 9/64 nozzle, and I've seen them in Target and some of the other stores here in the spring here. You're putting on, a 1/4 of an inch an hour there, and, you're running about not quite a 1/2 inch in 2 hours. Now, the thing I have to mention is if you're using like a 3/4 or 5/8 garden hose to hook these up, you start getting out there, 50 feet or more, you start to have friction loss. So, I would probably say if you're going to use the normal garden hose and go out there 100, maybe 200 feet, about 4 gallons per minute is about, the most you want to go through that, unless you want to invest money into like an inch PVC hose or plastic you can buy at the L&M or Fleet Farms or your local hardware store. Because friction has a lot to do with it. I have people that call me up and, they bought a system like this and they just, frustrated because they can't get hardly no water out of their things, but they're running 300 or 400 foot of hose. And so consider the friction loss as you go on. For those that are looking at solid sets, there's many spacings here. If you're into solid set irrigation, I can help you design your system for the right size pipes and that type of thing. But as a rule of thumb, you're going to need about 50 gallons per minute per acre on a solid set system. And that means you're probably looking at a pump, a well, a pipe, or some combination of that that's going to get you, 50 gallons a minute per acre. And the reason that 50 gallon has been triggered is basically because that's the minimum amount that you can get by for frost control to protect your crops somewhere down to about 25 degrees in the spring or 25 degrees in the fall. And when we're irrigating for frost, we want to use the least amount of water possible because, sometimes you have to run. The worst case scenario that I can remember that we started irrigating at 8 o'clock at night and ran till 11 o'clock the next morning one year when the strawberries were just in full bloom. So you can just see the amount of water that was out there by the time the ice thawed. So we tried to get by with a minimum amount of water when we're irrigating for frost, but a lot of us don't like to go around and change the nozzles all the time either. Again, there's all kinds of solid set design here. You have to think about, your soil intake rate, and again, sprinkler application rate. We look at nozzle size, pressure, and spacing. In the layout, we don't lay them out in a square. We like to lay them out in a triangle, so one line has one pipe and one nozzle. They're not across from each other. And another thing that makes a big difference of how far you're going to throw your stream of water is your sprinkler height, or the height of your risers. And if you look in the Johnny's catalog, they have these towers, and them towers will actually spray a long way, because a lot of them are 4 or 5 feet tall, and you can spray farther, but you only put so much water through them, so you got to think about where you're going to, if you have a circle that's 60 foot around instead of 40, then it's going to be a situation you just have to let it run that much longer. So anyway, all I can say about designing solid set sprinkler systems is, you can consult the local experts. They're not hard here. The university, we have put together a sprinkler irrigation systems handbook. It's Midwest Plan Service number 30. There's a website there that you can get them at, and that'll basically cover about anything you really needed to know on sprinkler irrigation systems, from well needs to the pipe friction and everything in between. So, when do we water with overhead? Here's some tips now. This is when we're watering for drought control. We try to water early in the morning, but it also depends on the crop. Drying of the plants is extremely critical. And we usually go out there, we try to do it in the morning, we usually have less evaporation, and that's really saves on water. It depends on the crop. We have to be very, very careful, but the bottom line is we want these plants to be dry as soon as we can. The worst thing that we can really do is to start irrigation at 8 in the morning, 9 in the morning, when they're just ready to dry off, and extend that time that they're wet. So I see that. We'll have to check that out here on that URL. I know it worked here a week or so ago. I checked it. The thing I want you to think about is the disease triangle. That's our next slide here. And this is how we determine when diseases will kind of come in. And if you look at the slide to the top in the yellow, it talks about you have to have a pathogen, which is basically the disease itself. Whether it's tomato blight or corn rust or whatever you can think of, you have to have a pathogen. Well, unfortunately, there's pathogens in the air all the time. The tomato blights, they can go, I've heard instances of 300 miles. I think that's awful high, but for them to go 50 to 75 in the wind is not a problem at all. So when the people west of you have diseases in their potatoes or whatever, they're going to be there. So the next one on your left is a susceptible host. So you have to have a host there that can get the disease. And usually what we're looking at is susceptible host is just another way of saying, the plant, whether it's a tomato plant or that. Now then the other thing that's very critical is the blue circle, and that's the environment. And the environment is what you can often control by making sure these plants are as dry as possible and dry up. Usually they figure 12 hours of wet is a very, very critical point for a lot of blights. When you get 12 hours of constant wet, they can start multiplying, and for those that have dealt with early blight, anthracnose, a lot of other diseases, they can just explode. But then if you look, on the bottom, when there's two circles that are intersect, you don't really have any disease. But when three circles intersect, like where the arrow points to where it says disease, that's when things get extremely explosive. So the environment could be wet, which is, what we're really talking about here. It can also be heat with wet, or with some diseases cool with wet. But most of the diseases that we deal with are dealing with moisture that cause them to be spread. Some of them can be spread by just high humidity. Some diseases have to be splashed from plant to plant. But the fact that you're controlling the environment with keeping these plants wet, can be serious too. Now this is where drip tape comes in really handy from the standpoint that the foliage is really never wet when you're using drip tape. They're under the ground. Drip tape is near the bottom or often under plastic more times than not. And so you're basically controlling the water. You're not flooding it, that type of thing. I know when you get 6 inches of rain and 90% humidity, we're in trouble. Nothing we can do about that. We have to look at going in with fungicides, whether you're organic or not. There's several out there that can help control that disease. So just remember this disease triangle as you get out there and irrigate. I want to move into soils. If there's anybody have any questions on the disease triangle or anything? Okay. We're going to talk a little bit about soil characteristics because that's extremely important with water use. And we look at drainage, is important. If you're going to irrigate overhead and you have spots in the field that flood, it can be very possible that they're going to flood, and maybe you ought to be looking at drip tape. The compaction layer limiting root zone, where the soil can only absorb so much moisture. But one of the big things we talk about more so is our soil texture. And the texture is something that we don't have a lot to do with. In other words, the texture is sand, silt, or clay. Soil structure we can control by adding organic matter, but the soil texture is something that they give you. I realize in high tunnels, people alternate that by hauling in sand, working it in. I'm working a lot of maybe sometimes bringing in some clay on sandy soils to try to get that perfect soil. But in a field situation, it's just not economical to do that. So we look at water holding capacity, and this is kind of one of the key things I want you to remember tonight. Before we get into that, we want you to remember that the majority of the roots of most vegetables and fruit crops are usually no deeper than 10 to 12 inches. And this is after they've been growing for 30 to 40 days here. So we kind of look at the amount of water that a soil will hold in the top foot. And then for some crops like onions and strawberries, we look at the depth being, about 6 inches. And these depths are normally achieved within 30 to 40 days after planting for most of your crops. they're either down there a foot or about 6 inches. Now, this is a very important chart here because of soil texture. Again, the size of your soil particles here. And this is the inches of water per foot of soil that, these soils will hold. Now you look at a coarse sand, you can get between 0.24 and 0.28, or almost a half an inch of water is what they'll hold per foot of soil. Now, a lot of people will say, oh, man, we just got 5 inches of rain, and things, we should have water for a long time. Well, sorry about this. Your coarse sands are still only going to hold a maximum of a half inch. The others may go through, it may run down into rivers and creeks and ponds and lakes, but that soil is only going to hold no more than a half an inch, which is going to be critical for some of the slides we're going to show you in a little bit. And then we look at that fine sand, a little over half an inch, 0.6 to not quite an inch. The finer the particles get. Then we look at the loamy sand, got some clay in it here, 0.84 to 1.44 inches of water. You get into your sandy loams, it increases, and then you get into your loamy clays, you can be up to almost a maximum of about 2.5 inches of water that soil is going to hold in the top foot. And this is, part of the reason why that I think we had such fantastic crops come out of the Red River Valley. That real heavy ground held a lot more water than we think about. And, of course, a lot of these new corn hybrids are bred just to go right down and get it. But this is going to be an important factor here, because if you have a crop like sweet corn or whatever crop you want to use, and it's using, a third of an inch a day, you're in a situation where you're going to be watering that every single day in a wind. The other thing we're going to go into is water extraction. And you cannot extract 100% of this. When it gets around 50, what we call 50 to 60% extraction, that's about as much as we can actually take out in many crops. So it becomes important. So if you've got a loamy sand here, and you're using a third of an inch of water a day, you probably got 3, maybe 4, maximum 4 days before you got to actually put that water in. Now, for a plant to use a third of an inch of water a day in field situation, has to be a crop that's really putting on their fruit, like when potatoes start sizing or corn starts making kernels, and there has to be some adverse weather conditions like wind with it. But that's when we usually run into trouble. So then your clay loams here, if you're using a third of an inch here, then you can go easily 6 days, 7 days, 8 days, sometimes not quite 8 days, but something in there to get it. So how often you got to irrigate controls a lot, and how long you run the irrigation system basically controls a lot. But as a rule of thumb, we don't like to run irrigation systems for over about a half an inch equivalent an hour. At a time, I'm sorry. This is just a shot here for you to kind of look at. It just kind of emphasizes what I actually talked about. This is just an example here when we irrigate. It's a drip tapeage sample, but you can see on the heavier soils here, the water comes out of the emitters and it spreads. And if you get your light soil like your sand, it just kind of goes right on down. So how we set drip tape, we'll get into that here a little bit later. This is a question we're just polling the people out there If you were going to irrigate, where would you be getting most of your water from? A lake, a river, a pond, groundwater, which is basically a well, city water, maybe you use a rain barrel or harvested rainwater or some other source. So we have the vast amount of coming out of groundwater, which is basically, wells, which is really nice to be able to use, and it has its reasons. We'll kind of get into that. So, but that's pretty good. Sometimes I do these, and people are pulling out of ponds and lakes, and that can create some problems, especially with drip systems. So anyway, let's talk a little bit here about drip systems and some of their advantages. And I think this is why most of you are actually here for tonight. So drip irrigation systems. We look at low pressure and small water supply can do an awful lot with the drip system. Remember I talked about there's almost zero evaporation. We can go in there and we can apply water during the heat of the day to kind of cool them plants down. So there's some real advantages here. High application efficiency, we use what we put on. A moderate labor, but it's easily automated. We'll get into automation here. But if you're not around every day or to check it or have a lot of fancy flowers you want to irrigate, you can buy timers and that relatively reasonable that'll set them things automatically for you. And then it works well with plastic mulches. We always think of drip irrigation and plastic mulch, even though you don't need to, in all instances, use drip tape with plastic mulches. I think about 70% of the time it is. Let's talk about some of the drip tape characteristics. For most drip tape, the emitters, or where the water comes out of, are manufactured in the tape wall. So you don't actually need to worry about putting them in. There are some exceptions. If you're going to bury the tape deep, like a foot or 18 inches, for permanent orchard or blueberries or something like that, then you will buy what they call, it's almost like a heavy PVC, and you will actually put the emitters in at the spacings you need them. But that's more rare than we would use for gardens or anything else. So for most practical purposes, the emitters are manufactured in the tape walls. Now, it comes in all kinds of spacings. In high tunnels, we usually look at about 8 inches. And in field conditions, we will go 12. If you're using vine crops, a lot of people go 24. About 24 is about the farthest apart the emitters should really be. So when you buy your tape, there'll be signias on it that'll basically tell you what it is. We'll get onto that here. Then you have a choice of how thick do you want this here tape. Well, you can buy it as low as 6 millimeters, which is, the same millimeters as plastic on tunnels or plastic they use for windows and houses. Really, really thin. And but we usually don't recommend the 6. The mice can chew it pretty well, and when it gets hot and dry, the drip tape sweats a little bit, and the mice they can chew right through it. So we usually like to start in with a 10. If you're in real sandy soil in the field, you can go to some 8. But for most practical purposes, we recommend 10. And if you're in an area that's rocky, it's not laying very well, that type of thing, then or in greenhouses and high tunnels, then we go to 15, where you have a lot of chance of walking on it and that type of thing. One question that I get an awful lot is, can we use it more than 1 year? And the answer is yes, you can. It depends on a couple of things here. One is your water quality. We're going to talk about water quality, because if your water quality gives you the possibility that's going to plug or something like that, you probably don't want to use it. I would probably say that the majority of the growers go ahead and get rid of it at the end of the year. It's not very expensive. I mean, a 6,000 to 8,000 foot roll, if you're going to buy one that big, is somewhere around $120, $130, and whereas you can buy it a lot cheaper. But if several gardeners or bigger gardeners were going to get together, I would recommend to look at one of them rolls and kind of share it, because the price drastically goes down to somewhere in the neighborhood of 5 cents a foot, 7 cents a foot. So it makes a big difference. And then we're going to talk a little bit about operating pressures, but with 10 millimeters, you can go up to 14 pounds, which we usually never go that high anyway. And 15 millimeters has a 25-pound break point. But, we don't usually irrigate that high. This is a shot of some irrigation testing that we're doing. It's a good shot. The ground was very, very dry. We put this in. What we were actually doing that night is we were testing fish oil, different fish oils, for plugging up in drip tape. You can kind of see the whiteness coming out of the tape. And we're trying to figure out which drip tapes, which fish oil concentrate would be well for drip. And I think we tested like 30 of them and only came up with one. At this point, that was done about 3-4 years ago, this test that really you could run the whole summer. And fish oil, I call it fish oil, but it's fish concentrate, is becoming a very, very important fertilizer for high tunnels and agriculture. It gives us a lot of yield. A lot better plant and food quality. We don't have a handle on it why. I have a student last year who did quite a bit of research. I actually set him up with some high tunnels down in St. Paul on campus. Did a lot of research, and the yield came out just unbelievable over using other organic. And most fish oils are organic. Some of them are approved, some of them aren't. But even if you're not in organic systems, they work really well. But anyway, getting back to the drip tape, you can kind of see how it's coming out of there. I'm on that dry soil, which was perfectly dry when we turned it on, and how it kind of just spreads around. This is just another shot here. People say, well, maybe I could go 2 foot. Or something like that in my garden out there when I'm doing melons and that type of thing. And you can, if your soil is a little bit heavier, you can kind of see the difference here in emitters between a 12-inch emitter and a 24-inch emitter. Of course, the 24 is on the right, the 12 is on the left. So that'll kind of give you an idea. You can also see how the water is also filtrating down on the right there versus the complete pattern here on the left. So, if you are using 12-inch part emitters for garden, that's pretty good. One question that I get is how far can you run drip tape? Well, technically you can go about 500 foot, pretty easy, or even longer if you go with a bigger diameter drip tape. But, we do what we call zoning then. We'll maybe put another header across so we can just cut the amount of water that goes through, at one time. So I'm going to talk a little bit about designing your drip tape system from very simple to very complex. This is what I call a simple system. It may be complex because you don't really need all this stuff. But we all can realize that the water is coming in over here from the well. And we probably all agree on most wells, the water's coming in there at somewhere between 30 and 60 pounds of pressure. And the drip tape should be running at around 10. If you're in big fields, maybe 12 pounds per pressure. So the first thing that we really look at is this thing here is a pressure regulator. It's completely mechanical, so that you put your hose coming in from the well into it. It'll reduce the pressure coming out to about 10 pounds. Now, for a lot of garden systems and all that, this is actually the only thing you need. And depending on when you buy them, they're $9, $10, $12. Everything is preset, so you don't have to worry about blowing up your drip tape or anything like that. So that's kind of what I consider the heart of the system. The only thing that you need to really know when you buy one of these is if you want a high flow one or a low flow one. Low flow ones usually go from, like 0 to 5 gallons per minute. It depends a little bit on the manufacturer. And then the high flow ones will go, quite a bit higher if you're going to be using a lot more water. So you need to know that. If you accidentally put on a low flow, all that's going to happen is you're going to get a lot less water in the system that comes out. If you put a high flow in there, then it probably could actually end up blowing your tape or something because it won't have enough back pressure to reduce the pressure. So after you've gone ahead and you've put that in, like I say, that's the key. Then the other thing I kind of say, well, you really should have a filter. And there's stainless steel. There's all kinds of different filters. These are the most economical ones. They're $15 to $20. They have screen filters in there they'll vary between 100 and 200 mesh, depending on really what you want to do. And you just kind of unscrew these, clean them, and put them back. There's also a valve here to open them up and clean them once a week if you would get any junk in them. They take out very minute particles of sand that especially comes out of wells. So that would be the next thing you need. So if you wanted a filter and a screen, you would start here and you would go to here, and that would be your system here. From there on out, you can start to get a little bit more complicated. You can, yes, the black things are the filters right here. And most of them look like that. They're called screen filters. So anyway, then if you're curious about what water pressure you got in there, you can go ahead and put a pressure on there just to kind of see what it's coming out at. Okay, and then at the end, you can put another filter, another screen on, another screen here to start with. We'll talk a hair bit about that. But then often, I recommend that you buy another pressure gauge just to make sure thing's operating right, that it's sitting in there roughly at about 10 pounds of pressure. Sometimes, like anything else, these things mechanically fail. But my experience is if they're going to do it, they're going to do it right away, usually when you get them. So anyway, so that kind of is our system. What we have here, and we're going to show you this on a different slide, is the ability to inject fertilizer into the line. Whether you're using fish oil or fertilizer concentrate, whatever. And that's where you use the second screen. So in case you'd have some particles or something from the fertilizer. If you're not absolutely going to use any fertilizer and you know you're never going to use any, you probably don't ever need that second screen. But, because fish oil and all these fertilizers, they just often don't dissolve really right all the way. Now we can get a little bit more complicated. So let's look at our system here. We still have a pressure regulator and a filter, okay, and we have our pressure gauges. And all this thing does is let out excess air. We usually don't use them that much because the air and the holes in the drip tape usually take care of that. I just wanted to put that on there to show you that, what they can do. So this is, from here on, here, it's kind of the basic system I showed you before. And I'll just show you this. It comes out here. They've got valves, so this way it's going to your garden, and this way it's going into your high tunnel, so you can do it all with one system. Now, let's start at this end here. We see our hose coming up from the well. We're following it up. This fellow's going to use fertilizer, so we put on what we call a check valve or a backflow device. And that would be if your well ever shut down or some freaky thing ever happened, especially if your well is lower than your high tunnel, it won't let anything backflow into the well. With a system this small, it's not quite all that critical, but with bigger systems, you can get a lot. And actually, the law is on any type of a bigger system, these are required here, and you really need a permit to do this. Not on a small system like this, they never said anything, but you get into a solid set or a center pivot, you have to have backflow devices here. Okay, so anyway, we have the backflow device. Then the next thing we have is a computer, or a control timer. Now, I'll tell you, if you're going to build a system, I would highly recommend that you put some type of a control timer on there. You can buy them very inexpensive at hardware stores or box stores, Home Depot, Walmart, that type of thing, for $5 to $7. A cheap one will basically give you a timer where you can maybe time them up to an hour or 2 hours and walk away. When we first built our first drip tape systems back 12, 15 years ago, we didn't have them, and then you'd wake up at 3 o'clock in the morning and you'd say, geez, I wonder if I shut that off. Well, you'd go out to the high tunnel and there'll be water laying all over the place. So at least invest in something that's going to shut it off for you so you can walk away, go to town. You don't have to worry about it. But then if you want to get a little bit more sophisticated, these here are computer, they've got a computer in there, computer control timers. They run $60 to $80 depending exactly on the model that you buy. With them, you can set the watering up to 4 different times a day. You can program it ahead up to 30 days. There's almost nothing that you can't really do with them. If it rains and you're outside, you hit a switch and they snap off. So, a really, really good investment. Okay. Then there's an extra pressure gauge here. This is our first filter that I showed you. And then this is where the fertilizer is injected. And we're going to have a different slide here. This is a tank here that's built by Chaplin Company. They almost have the monopoly on it, but I see the Walmarts of the world and that sell them too, but they kind of have but anyway, what happens here is you put so much into your fertigation tank, however much fertilizer or fish or whatever you're using in there, and it takes it out very gradually, so you may need it filled once a week or once every 2 weeks. There are settings on there that will do the right mix, whether you want 100 to 1 mix or 50 to 1 mix or something like that. So they're not cheap. They'll vary between $30 and $100 depending on how big a one you got. I think that's a 3-gallon one there. So, that's kind of the complete system here. I mean, bigger high tunnels, bigger gardens will use bigger pipe. This is all 3/4 pipe, but this is kind of it in a nutshell here. Okay. Going across the top of what we call the header. And all a header basically is a fancy word for a pipe or a PVC pipe. There's so many different types out there. This is what they call a compression fitting, where once you push the thing together, they don't come out. They compress internally, and a lot of people like them. This is your drip tape that just screws right into that. So, most of the people in the high tunnels, if you're looking at that, have went to solid white or gray PVC pipe. They now have elbows that glue into there that you can just put them on. They're so nice because if you want to change your spacing, you just shut them off, cut your pipe in two, put another elbow in, and come out in another spacing. So, and they don't leak. I mean, I've worked with drip irrigation all my life, and I've never seen any of these other black headers that didn't leak. This is what they call flat lay tape here on the bottom right here. And it's, the drip tape is actually poked in there after you make a little hole with a special punch. It's okay, but it's going to leak. And if in your field conditions, it doesn't make a lot of difference, but you start getting into high tunnels, the greenhouses, and that type of thing, you just don't want it leaking. It's just a real pain in the neck. So anyways, a shot of some drip tape systems there. Okay, drip tape flow rates here. At 10 pounds of pressure, okay, like I say, there's two of them that we highly recommend, and one is the ones that are 12 inches and ones that are 8 inches, especially if you're working in a high tunnel here. So this is the one that's a foot apart, and when you buy drip tape, you'll see two numbers on there. One will basically be the gallons per minute, and the other will be how far the emitters are apart. So the number would be like, here would be 12/45. 12/45 means that the emitters are 12 inches apart, and it'll put out 0.5 gallons per minute per 100 foot. Now that's not a lot of water. You take a 100-foot high tunnel that has 5 rows in it, you're looking at 2.5 gallons a minute. Let's look at this one here. This is 0.67 gallons per minute. This is the 8-inch apart emitters, and that's 0.67 or 2/3. So that basically means you're using about 2/3 of a gallon per minute per 100 foot. Well, you multiply that out, with 5 drip tapes in a tunnel or whatever it is. I mean, you're still looking at, a little over between 3 and 4 gallons per minute, which is, a very, very small amount of water here. But if you look at, how much do you put out per hour? 27 gallons per hour per 100 foot of tape. So, again, usually when we run drip tape, we usually run it for an hour at maximum in the high tunnel, maybe a little bit longer, out in the garden here. So you're not using, a tremendous amount of water. So I just want you to remember that figure. The first number will be how far apart the emitters are, and the next one will be gallons per minute. And actually, if you look at it, the 12 here and the 8 have the same size as the emitters. It just puts out more water because they're closer together. Any questions on that? Okay. One question that comes up is, do I want to run one line or two lines per row? Well, as a rule, we use one line per row. Some growers are actually using two with an emergency line that they only hook up one line. If something goes wrong, they'll have it hooked, be able to hook it up, especially under plastic. When we do crops with very limited root systems, like strawberries, for instance, we actually are recommending two drip lines per double row. We'll show you some pictures here in a minute. So here's just a picture of a drip tube placement here. Single row crops, tomatoes, cucumbers, and melons. And you can see here, 4 to 5 inches maximum. The drip tube is basically from the stem of the plant. You get it too close, it's very touchy here. You get it too close, and it'll actually rot out the stem because it'll be shooting out water. It'll constantly have the stem wet. If you get it too far out here, it's going to pull all your roots out here for water, and it's going to be lopsided. So, that 4 to 5 inches, and I always look at 5s are really on the high side. I like to kind of keep it around 4. And you can see that's buried just a little bit. We'll get onto that. Here's the double rows. And if you're using like eggplants, peppers, some strawberries, you can still get by with one drip tape because these type of plants aren't really kicking out, that much use for water here. So we do use some a single row here for some plants. Let's talk about the drip tube placement here. This is something that a lot of people get a little concerned about. So you'll be able to see on the bottom of the drip tape that it looks like it's sealed. It's like I got one great big long seam in it. And that seam is where the emitters are. But that always goes up. Now, a lot of people would say, geez, I'd really like that to go down. It just makes sense. The water is dripping down and that type of thing. Well, you can run into some problems doing that because when that drip tape shuts down, it's going to create a little bit of a suction. The water is going to be in on it, and it will have a tendency to suck in a little bit of dirt and some other problems. So what we always say is you want your emitter side up, okay? And to keep the tape from shifting, we kind of like to bury it 1 to 2 inches. 1 inch is plenty here to keep the temperature down because you got a long tape, and if you have it on top and all of a sudden the temperature goes sky high in there, it's going to stretch. Then at night it cools down, it's going to contract and it's going to buckle on you. So the burying it also helps with the buckling, that type of thing. Of course, you want to avoid puncturing tubes during planting and staking. And they do have all kinds of fix-it tools that you can put tapes together. If you would have a serious situation where you cut a drip tape with a knife or anything like that, they have fittings that you can just screw them right back together. So it's not the end of the world, but it sure is disgusting when you go out there and there's water all over the place because somebody punctured it. So anyway, this is a shot here. We're looking at burying a drip tape. You can see our assistant there, how she's laid the tape on beds here in our one high tunnel, and she's actually burying it. And it's probably more important that you're going to do it in high tunnels, but most of the people that lay plastic actually, got to the point they bury it. The automatic plastic layers that lay the drip tape with it will actually bury it for you. Here we are. So after the drip tape is installed, we actually put on the plastic mulch, just kind of work it in. So you can see here on the lower right here where the drip tape is basically coming out. Then we're ready to kind of hook it up. It actually hooks up at the other end in this tunnel. Next thing we're going to talk about is monitoring the system. Linda's right with it here. So the question is, when is water quality the most important? In an overhead system, in a drip system, with a groundwater source, or with a surface water source? We still got a few coming in. Well, actually, both the drip system, the groundwater source, and the surface water source are extremely important. The groundwater quality. In a drip tape, water quality gets to be extremely important because you can have plugging problems and all kinds of grief. So, when you think about water quality, we talk about algae, that type of thing here. So, we think about groundwater here, and there's two elements that we have some serious problem with it, and probably the main one that we deal with in Minnesota is iron. There's certain parts of the state here that the iron in the groundwater wells are so high that we have to actually participate it out before we put it in the drip tapes, because it'll just plug the drip tapes every week. So we just kind of do that by sprinkling it through a barrel. There's actually a system that we go ahead and do that with. But iron is very serious with drip tape for plugging. The next one is calcium, but it's a loose calcium, where the soils are so high in calcium that they actually form almost hunks of calcium. And I think we've seen that in water pipes when we tear it apart. So, calcium isn't as big as a problem. And then we have sand, which we talked about before. We have sand filters to take it out of groundwater, or we can use screen or disc filters. If you're going to take it out of a pond, or river, surface water, then we run into algae, silt, and sand. And even though that may look really rough, we have what we call actual sand filters. And, an average one is somewhere around $350, and they will actually take all of them out. They run it through a P-rock. There's some other filtering in there, and actually do a really, really good job. Now, if you're running it through a solid set system and you had a nozzle in there that's an eighth or, bigger than that, you're probably not going to have a problem. But going in with a drip tape, with a small emitter like that, you're probably going to have to look seriously at some type of sand filter tanks or something like that with surface water. And it sounds expensive, but on the other end, if you have a really good source, probably a lot cheaper than building a well. Okay, so filtering systems, we have what I call the sand filters, and what other type of filters do we have? Does anybody else want to take a guess on that? Okay, guess not. So we have the sand filters. We talked about the stainless steel filters, and then we have the disc filters. The disc filters are kind of in between. They actually filter through different cloth type discs. They're relatively inexpensive if your problem isn't too bad. But if it's pretty serious, then you're going to have to go through some type of sand filtration filtering system. Like I say, for most wells, that inexpensive filter we talked about in the beginning is probably the way to go. Irrigation timing. Okay, this is a slide here that we actually did with a computer model in 2005 in a high tunnel at Staples. But it doesn't make any difference if it's in a high tunnel or if it's in a garden. The same principles apply. Now, geometrically, we do a curve here that tried to represent the average amount of water use that we were using, starting with the 29th of May, and of course, the plants weren't all that big yet, and you can see during the growing season. The week around the 19th of June, the tomatoes were really starting to form. Very, very high heat. We were using a average of just not quite 4/10 of an inch of water per day during that week. I'm sure it was a hot week, cloudy week. We can relate all this to temperature. Then we move into the next week. Well, you say, gee, what's going on here? The tomatoes should have really been harvesting. Well, they were, but the weather cooled down, probably a little bit cloudier, and the water use just really wasn't there. The following week, probably a little bit warmer, and, we used a lot more water. Here we get farther on in July, you can kind of see here. We had a really hot week, the last week of July. You can see our water is, really up there. Early in August, then you can just kind of see it, working on down. So, I guess the point here is that we're going to have to come up with a way to kind of monitor our water use, because if we said, well, we're going to go by the curve and we're going to say, well, when we're harvesting tomatoes, we got to put the equivalent of a 25 or a quarter of an inch of water a day on here. These tomatoes are going to be pretty sick here. By the time you get into here, there's going to be all kinds of blossom, end rot, and other disease problems here because of lack of water. So putting the right amount of water in at the right time is extremely important here, on whether you're in a high tunnel or whether you're in the garden. Okay, so we have significant fluctuations from day to day. That's based on weather conditions. So we have this gadget, what I call, it's called a tensiometer. And we're going to talk a little bit about tensiometers here, because they're, I really think they're a key to, if you're in high tunnels or gardens. We use them a lot with the big irrigators that are using center pivots, and they all work the same. All it is a hollow tube with a porous ceramic cup on one end. The tube is filled with water, sealed with a cap, and has attached vacuum gauge. Sounds very complicated, but it isn't. Tensiometers read in centibars. And a centibar, when a plant extracts water out of the soil, it creates a vacuum. And that's what we're reading. It isn't the vacuum like you get with a house vacuum cleaner that goes whoosh. These here is vacuums that probably isn't even, measurable by most common means. But we do measure them in what we call centibars. That really isn't important to remember, because these are what we call tensiometers, and there's a lot of makes here. These were made by Irometers. You can tell they're actually made from other countries too, but I just show you the gauges on them. Here they'll start at 0 and they'll go to about 100. and 0 is where the ground is completely wet, won't hold any more water until you can start getting up into this range here. You're starting to have plant wilting, and by the time you get up in here, it's pretty well all over for that particular plant for the season. They come in all kinds of different lengths. Usually what we tell people is, you know, 6 inches, you want to know what the water is in the top 6 inches. So, that's what we measure. Some of the irrigators will go down to a 12-inch one here, 1 or 2 in the whole field. That's kind of up to you here. And then if you really want to get, more sophisticated, you can spend about $500 for these here soil block monitors. You can run about 6 off of one computer, and they just register everything else. The nice thing I like about these mechanical ones, you can go in there, you take a look at them, you can watch them every day, and it doesn't take long for the things to really change around. These are just some of the electronic ones here, not really used all that much as one would really think. So, as the plants use water and the soils dry out, the water is drawn out of the tensiometer through the ceramic cup. We have the suction. The tube is sealed, the vacuum is created, and is measured on the gauge. Okay, low readings like 10 centibars is relatively easy for plants to extract water, and at higher readings, the drier soil is, the less water that's available to the plant. Probably more than you really need to know at this particular point. But it really is important, whether you're outside or in a tunnel or wherever, that you do a water assessment from time to time. Now, maybe you don't need a tensiometer. Maybe you could just use a soil probe, stick it in there, give it a twist, and see how dry that soil is. And you can kind of, get a feeling of it if it's starting to turn dry or if it's, really, really wet. And, there's the old saying that the eye of the master fattens the cattle. Well, it's kind of the same with this. You pick up some experiences. It works really good. For small gardens, was going in there with the probe, but you really need to get a handle on that water system and not wait until the plants start actually wilting here. This is a chart here, and I'm not going to spend a lot of time on it here. Maybe I won't. Okay. So here we are. This gets a little bit complicated too. That's a good question. How many centibars before we turn on the water? So basically, as I said before, when the water is near 0, the ground is saturated. Okay, that means that it really, there's probably a little bit of free water floating around here. You pick it up, and it's almost kind of like mud here. And then as the water comes extracting here, at 10 is still pretty wet here. And you kind of work it up, and you get to 20, you're still pretty safe, but it's starting to suck the water down. Then you get up to around 30, and that's usually the trigger point that we tell most growers that you actually really want to start watering. And with that in mind, they're not going to let it go. They're not going to be able to do it at 30 all the time. So, you get up into the 40 range. Once you're up to 45, that plant's starting to really suffer a little bit already. So you want to be concerned about that. So what we tell most growers is, 30, between 30 and 40, I like to see it turn down around 30. Now, in a high tunnel situation, you can go from 10 to 30 from like noon till 3 or 4 o'clock. They'll take that much water on a hot day. In a field situation, it may take you, a day, sometimes 2, depending on your soil type, to raise it like that. And that would be under, maximum water use conditions. So, But once you get up into here, in the 60 to 70, you've got you got plants that are wilting. Once you get up into 80, they're basically, dead for all practical purposes. So, but usually around that 30, 35 range, That's a good question about the fruit trees. They definitely have a deeper root system, and all these factors affect them, because really, if you look at the major root system of an apple tree, it's really in the top foot of the soil. I'm sure it goes down deeper than that, but that's where most of the feeder roots are. So the apple growers usually will run ones that are about 12 inches. Good question, good point here. The thing with running a 12 inches that it takes that much more water to be able to, get everything good and wet too. And just from my experience for the years, and when it starts getting sucked down at the bottom, it sucks it off the top and the bottom together. I mean, the roots usually just aren't in the top inches of soil unless you're looking at something with strawberries or all that. So we usually go a little bit deeper with, with fruit trees. You can go down to 24 inches. I think that's kind of really pushing it a little bit. Okay. Kind of an answer to your question here. Here's a deep tensiometer here, and here's a shallow one here, the 6-inch one. The cost of these vary here. I'm looking at the commercial catalogs. The 6-inch ones are around $50, $55, depending exactly where you buy them. The thing with most tensiometers, you put them in the spring, and they basically last the whole season. They do have a few, I see in Johnny's catalog, and some others that will give you a soil reading, a tensiometer soil reading, almost instantaneously. Got to be careful if they're looking at percent of soil water, if they're looking at centibars, or really how they're actually measuring it. But there are other types out there. These are definitely the most accurate, the ones that are put in permanently. Very good investment. If you're inside a high tunnel, I would sure have one on every single row, especially if there's different crops. But you can kind of, and somebody goes through that tunnel every day, just glances at them, make sure no freaky things happen, like one of the drip tapes plugged or something like that. So very good investment here. They'll last for years and years and years and years. So I guess this kind of answered our next question on them. When root zone tensiometer reads 30, 35, and 40, we usually begin watering. And when it drops down to 10 or below, we stop watering. We have to realize that the root system of a plant, say a tomato, outside of a high tunnel is probably at least 2 to 3 times greater than it is inside a tunnel. So it can extract more water outside. The flip side is when it gets drier, it's hard to replace it all. We want to spend a little bit of time on chemigation and fertigation here with the sets. But before I do that, does anybody have any questions on tensiometers or anything up until we are right now? Okay, if not, we're going to go on with chemigation and fertigation. And what is a good iron filter? Okay, you can usually use a disc filter if they're not too bad. A sand filter, some of the sand filters will take out iron. If it's really, really bad, then you're going to have to go to a system that will actually take it out above the ground and precipitate it out. We can talk about that later. That gets, okay. Can you use salinity affect a tensiometer reading? Usually not at all. Can you use a longer tensiometer as they should? Yes, you can. The only thing that really counts on that tensiometer is that bottom 3 or 4 inches where that ceramic, what I call ceramic filter is. So that's a good question, and that's basically it, yeah. So, yeah, if I have a intensively planted bed of carrots or beets, say 6 rows, should I use more than 1 drip tape? Yes, you can usually only run 2 rows of anything on a drip tape. If you try to go out that far, your 2 rows will be way over watered. We tried that here this last summer. We put a August crop of carrots in the high tunnel, and I really watered them. I didn't want to lay a second row of drip tape. The ones next to the drip tape were kind of forked and all that, so I overwatered to get water out there. So we usually recommend 1 drip tape for 2 rows, no matter how far apart they are. Okay. Anybody else? We're going to go into chemigation and fertigation, and all that is the application of nutrients through the drip system. It can get pretty technical, but I've learned through the years that I basically take the technicality out of it. Do you need to know the flow rate of your system? Well, if you're going to go in there with a very expensive piece of machinery to do that, you really need to. You need to know about nutrient interactions to avoid clogging and that type of thing. Yes, if you're mixing your own fertilizers, you need to be a little bit careful there. You need the calculations of fertilizer quantities. And that's really true in our high tunnel manual and field manual. It'll basically give you the amount of pounds of different fertilizers you need. In a tunnel, it takes very, very little. Then also the fertilizer requirements of the crop that's really grown. Now, one thing I want to say right here is that it's just about impossible to supply enough nutrients to get a full crop during, with just fertigation after the plant is in. I mean, we've done quite a bit of research with that. So basically, we always say you want at least 50% to 60% of your nutrients put down before the plants are in the ground, whether that's compost or commercial fertilizer or whatever you're going to use. Anyway, you need to have. Don't depend on fertigation for all of it, because for some reason you can't get it through. The absorption rates are low. There's some other problems there too. I guess I showed you this slide here, so we'll go on here. There's many types of fertigation systems out there, depending on what you want to use. This one here is a double dosatron with a filter on there. They're in the neighborhood of $700-800. They inject the fertilizer out of a barrel or something while the drip tape is running. The nice thing about them is that they're automated. The drip tape kicks on and they're going to kick on. This is just a single one. Single, like a dosatron here, is sucking water or the fertilizer out of that barrel and putting it into it. Again, about $250 for that unit there, depending on where you buy it, but that's a good rough figure here. Okay, probably these here too, you know, I'm kind of the person that's a little bit more simple-minded here. After I burned out a pile of these here, dosatron, that type of stuff here. Next, we got this here type of a system here that I explained to you before, where you actually go in, you put enough fertilizer in there for it to sink as a week. Every time you run drip tape through, it runs the fertilizer through the system. Okay, and then this is what we call batch loading a system. And it's probably used more and more all the time. First of all, it's very simple. You just go down to one of the box stores or your favorite hardware store, buy yourself a sprayer, a 1 or 2 gallon sprayer. You cut the end off of it, and before one of the filters, you actually put a little valve in there so you can turn this baby on and off. And then what you do is you put as much fertilizer in there as you want for a week or 2, whatever you want. All the research that we have done, we do not get any better yields with watering or fertilizing once a week or every day for most crops. So once a week is kind of the pivotal point if you're adding a lot of extra fertilizer. And usually that's only during the major crop utilization. Once tomatoes start turning, or even before, they're going to need a lot of fertilizer and that type of thing. So anyway, this is a very, very simple hookup. You put your fertilizer in here, usually 1 pound to 2 pounds, depending exactly what it is for a garden or a high tunnel, or it could be more for a bigger garden. You go ahead, you got your tube coming out here with a valve. You pump this up, but before you do that, you start your system up. On any of these systems, the drip tape has to be completely functioning and working up to par or to maximum before you start injecting fertilizer. Otherwise, it's not going to go directly through the whole system evenly. If the drip tape is very soft, because you don't have the pressure built up, it's going to just come out, a lot earlier than you want it. If it's really soft, it's just going to, just roll in there. So the idea is get that system up, run it for 5 minutes, maybe 10 minutes, and then these other systems, whatever you're using, should be kicked on then. So anyway, so after your system is up and running and good, and you can look at the gauges, they'll tell you it's up to 10 pounds, and I still wait about 5 minutes. And then I just go ahead and pump this up, turn the valve on. It'll take your fertilizer right straight through here into the system, through the filter, and then into your high tunnel or your garden or whatever you're using. Very, very simple. Nice thing I like about it, first of all, it's cheap. You probably got, $10 or whatever these here plastic sprayers cost, and you got the price of a valve, maybe another $10, so $20, $25, and you got yourself a pretty good system. You know exactly what you're putting on. The thing is, you've got to manually do it once a week or whenever you want to do it. These other ones here, they will kick on with timers automatically. You can get them set up. So whatever you really want, there's several options out there to use. They say the eye of the master fattens the cattle. If you're getting into really hot weather, you may want to be putting a little bit of calcium on there. There's organic and inorganic forms, that type of thing to guarantee more calcium uptake. So, but whatever, I just wanted to show you some different ways to fertigate without spending, a pile of money here. Not going to go over this here. Fertigation systems, determine the time to apply water, determine the amount of solution for a single fertigation, run the system so that the fertigation is complete. And that's kind of important. We usually like to have you run it about 30 minutes before shutting the system down, so it gives the chance for the water, for the fertilizer to go completely through the system and completely get out. We've done dye tests where we actually ran dye through the system, and as long as the system is up and running before you inject the fertilizer, the system itself will just equally run it through and filter it through. So the other thing you need to be concerned about, especially in gardens, is over-irrigation and leaching the nutrients out of right out of the groundwater, right down to the groundwater. You need to think about if the fertilizer is compatible with water. Most of you, you'll be using something like a Miracle Grow or something like that, which you don't have to worry about. If you're going to start mixing phosphate or sulfate, some phosphorus fertilizer and that type of thing, you better get some advice here. And then a suction line in the fertilizer tank should not rest on the bottom. You may have, if you got one of them sprayers, one of them hand sprayers, make sure you cut it. The suction tube, so it's an inch or so from the bottom, so it don't suck up stuff that's not dissolved here. And get one with a small screen is highly recommended. I'm not going to go into this chart. It just, you can look at it at your leisure. It just talks about the rooting depths of different products there. Are there any questions here on fertigation? A lot of the insecticides that people use, especially in the big potato country or out in California, are actually injected through the irrigation system and brought up from the plant. They're called systemic. Don't do a lot of that here in Minnesota, and us that are organic or sustainable usually don't do that. But I just pointing out that there are a lot of other options other things that you can do with your irrigation system that are very beneficial out there, and I didn't really cover them all tonight. Any other questions on fertigation? Okay, quite simple. Extension materials that are available out there. Our Minnesota High Tunnel Production Manual has a big line on there to use, and actually there's another website for that. It's www, then go to, just put down hightunnels.cfans.umn.edu. That's hightunnels.cfans.umn.edu, and that will take you to the High Tunnel site. And we just updated that High Tunnel manual in the past couple, 3 months. If you're really into trickle irrigation, the trickle irrigation for the eastern United States is a really good manual to get a hold of. The High Tunnel manual online, I think this is here online here. High Tunnel for Central Great Plains, written out of Kansas. Pennsylvania has one here. Plastic mulches and drip tape for vegetable production and micro irrigation too. So there's a lot of extension materials out there to get you going, and if you have any questions out there, most of them you can actually download. So I think we're going to see if there's any questions, and I think we had one more little thing here coming up, huh, Linda?
We just had 4.
Oh, okay. We did 4?
That source one earlier. So we've done all 4.
Oh, okay. Okay, good. Okay. So I guess it's time for questions. If anybody has any that, they would like to shoot up and kind of end our session here.
Do you recommend grafting tomatoes?
The question is, do I recommend grafting tomatoes? We have to look at the history of grafting. It actually come out of China, and the reason the Chinese developed it is that their soil is so old, it's been used so long, they have lots of tunnels out there, and they have real bad disease problems. So the graft that we use, it will give us tremendous disease resistance for soil diseases. With that said, if you get out to California, they're doing a tremendous amount of grafting to, control their soil diseases. When they lost methyl bromide now, and that type of thing. So, yes. Will it work in good conditions and give you more yield? Yes. It will to a certain point. But so a lot of people are grafting, especially where they got their real estate's really expensive, like under high tunnels and all that. And the disease control is with root diseases and not so much with leaf diseases, at least at this particular point. So, really interesting. Grafting is a science by itself. How wide are beds in a high tunnel and distance between? It varies quite a bit. Usually 3 to 6 inches high, probably about 4 being average. And then between the beds, center to center, in Minnesota, we usually go with 4 foot. Now, once in a while, some growers like to go 5 with tomatoes, where they're going to use a floor to weave and they're really, really thick. But 4 foot is pretty well the standard industry here from bed to bed.
Terry, there's a question by Donna. Oh, you made that one already. So there's one here from Staples about iron in water that plugs fertigation systems.
Yes. Yes. I think what you mean is the drip system more so than the fertigation system. Unless you have electronic fertigation system, then you can run into some serious problem there too. Usually they have iron filters that you can put in. It all depends on the percent of iron. You can use a disc filter, you can use an iron filter, but there's a couple of growers up near International Falls that the iron is so bad, what they actually do is they have a big round, what I call a cow watering tank, and they actually spray the water through that before they use it into the high tunnel, into the drip tape, I should say. Then they pump the water out of there with a small pump. And by hitting that steel, the water precipitates, or the iron precipitates out of the water. Now that's kind of the worst case scenario, but it's something that can happen. But you can always give me a call. My number is 218-280-7713 if you run into any serious problems that you need a little bit more guidance on here. We can be glad to talk to you about it. Maybe come up with some solutions.
And Jeff has a question.
Okay, in the high tunnel, I plant my tomatoes. That's a good question. I'm just talking about that today with another fellow here. When you plant your tomatoes, you'll have the drip tape on one side of them. And on that side, if you're just going to go with one side, like planting lettuce, you can get by with one drip tape, because that one drip tape will move out about 6 inches on the outside and take care of the crop of lettuce. If you're going to go with companion crops on both sides, then you got to have 2 drip tapes. And with the money you can get out of, or the crop that you can get out of using 2 drip tapes, if you can run companion crops on both sides, is well worth it. Because you can set up a second drip tape that you don't have you can shut it down when you don't need it. Okay. Parts per million, I don't think so. I think you're on the line there. I think you should be okay, but it would be good to, I could kind of check that out for you. I really can't remember, but I think you're on the low side.
Talk button.
Okay.
Sorry about that. So next week on Monday, we have the Farm to Cafeteria workshop in Monoman, and we are not having class on Tuesday. So the next time for Local Foods College will be February 12th. Please, before you sign off, there's a link to a survey right near the bottom of the chat box. I'd invite you to open that up, and your email on the cover slide. We put that email in again, Terry.